And gentlemen, this is Ms. Hummert here. Today we're going to be doing Unit 7, Notes 8. So we're going to be talking about combination word problems. So we're going to be applying them to given situations with that formula that we used on the previous note sheet. So let's first talk about what a combination is. It's an arrangement or listing of objects in which order is not important. So when we did permutation, the order mattered. We talked about arranging a line. Okay, then order mattered. Putting things in order or rank, order mattered. Now when we're talking about combinations, the order doesn't matter. So you want to make sure you get that formula written down again so you have it for when you do the combination. Okay? All right, so let's go ahead and let's take a look at some word problems. So for number 1, it says a basketball league has 5 teams. 2 of the team are chosen to play one another. How many different ways are there? Well, does it matter the order in which we choose the teams? No, because ultimately 2 of the teams have to play each other. So we're starting with 5. And then we're going to choose 2. So we have 5 factorial. And now we're going to do 5 minus 2 factorial minus 3 factorial. So then we have 5 factorial, over 2 factorial. Boop, there we go. Over 3 factorial, 2 factorial. So let's look at it this way. So everything from 3 on down is going to be taken care of by that guy right there. So left on top, I have 5 times 4, and then I still have that 2 factorial right there, so 2 times 1. Well, 5 times 4 is 20. 2 times 1 is 2. 20 divided by 2 is 10. So we have 10 different ways that we can choose those team lineups. So let's take a look at number 2. So for number 2, there are 7 seniors, 5 juniors, and 4 sophomores that have volunteered to be peer tutors. Mr. Picard needs to choose 12 students out of that group. Well, let's figure out how many total students we have. We have 7 plus 5 plus 4. So that's going to give us 16 total students, and then we're going to choose 12. Does it matter the order in which we choose them? Not really. We're just trying to look for a group of 12 students. It doesn't matter the order in which we chose them. So we're going to do 12 choose 2. So we have 16 factorial, and then we're going to divide that by 16 minus 12 factorial, and then times 12 factorial, because again, the order doesn't matter, so we're using that combinations formula. So let's go ahead and let's simplify that down some more. So I have 16 factorial divided by 16 minus 12, which is 4 factorial, times 12 factorial. Well, 12 factorial is my bigger factorial, so everything from 12 on down is going to be taken care of there. So left up top, we have 16 times 15 times 14 times 13. And then once we do that, we're going to take 4 times 3 times 2 times 1 in that leftover factorial. So now we need to go ahead and we need to divide that out. So let's go ahead and let's take a look at what that looks like. So 16 times 15 times 14 times 13, that's going to give us 43,680. Divided by 4 times 3 times 2 times 1, which is going to give us 24. So then there's 1,820 different ways that we can assign those groups of juniors and seniors. Next, let's take a look at number 3. You and 6 friends are going to eat lunch. You can only take 2 people with you in your car. So we have 6 total friends that we're choosing them. We're going to only pick 2. Does it matter which order we pick them? No, it doesn't. It just matters that we pick 2 of our students. So we have 6 choose 2. So then we get 6 factorial divided by 6 minus 2 factorial times 2 factorial. So then we get 6 factorial, 6 minus 2 is 4 factorial, and then 2 factorial. So then 4 factorial is our larger one. So in 6 factorial, everything from 4 on down is taken care of. So we have 6 times 5 left on top, and then on the bottom we still have that 2 factorial, which is 2 times 1. 6 times 5 is 30, 2 times 1 is 2. 30 divided by 2 is 15, and then we have ways. So there's 15 different ways that we can arrange those students in the car. So let's take a look at number 4. So a gym coach selects a team of 4 athletes from 14 athletes to represent the school at the track and field meet. So we're not talking about the order in which they place in the track and field meet. We're talking about actually the number of students that we can take and the orders that we can take them in different groups. So there's 14 total students, and we're going to choose 4 of them. So then we have 14 factorial divided by 14 minus 4 factorial times 4 factorial. Again, it's a combination. The order doesn't matter. So then I have 14 factorial divided by 10 factorial, 4 factorial. So the larger factorial is 10. So everything from 10 on down is going to be taken care of in this factorial. So left up top, we have 14 times 13 times 12 times 11. And then on the bottom, we have 4 times 3 times 2 times 1. So then we're going to take and we're going to multiply out the top. 14 times 13 times 12 times 11. And that's going to give us 24,024. And then we have 4 times 3 times 2 times 1. And that's going to multiply by 24. So now we're going to go ahead and we're going to take 24,024 and we're going to divide it by 24. And when you do that, you get 1,001 ways. Next, let's take a look at this last problem. Mr. Pasham is trying to split up his class into groups to review for finals. He has 16 students and wants to make groups of 5. So here's a hint. Whenever you see something that's talking about groups, that typically means combination. Because when I'm making groups, the order that I make groups doesn't matter. It just matters the different types of group that we can make. But no one within the group is in the order. So that's why it's a combination. So we're going to have 16 choose 5. So that's going to be 16 factorial divided by 16 minus 5 factorial times 5 factorial. So then that's going to be, whoa, hey Pandora, that's going to be 16 factorial divided by 16 minus 5 factorial, which is 11 factorial, times 5 factorial. So everything from 11 on down is taken care of in that 16 factorial. So left on top we have 16 times 15 times 14 times 13 times 12 left on top. Then on the bottom 5 times 4 times 3 times 2 times 1. So let's go ahead and let's multiply out the top. So we have 16 times 15 times 14 times 13 times 12. That's going to give us 524,160 on top. And then we need to divide that by 5 times 4 times 3 times 2 times 1. And when you divide that out, when you multiply that out, you get 120. So now I'm going to take 524,160 divided by 120. And when I do that, I get 4,368 ways. So that right there is your final answer for number 5. Last but not least, let's take a look at this review problem. So we want to solve these in the zero product property. So if we're going to solve this, that means that our y is going to be equal to 0. So now we're going to go ahead and factor this. So we're going to multiply to 1 times 8, which is 8, and add to 6. So to multiply to 8 and add to 6, you're going to have 4 and 2. So then I have x squared plus 4x plus 2x plus 8. So I split up that b term to be those 2 points. And now I'm ready to factor by grouping. Between x squared and 4x, I can take out an x, and then I'm left with x plus 4. Between 2 and 8, I can take out a 2, and I'm left with x plus 8. Or x plus 4, because 8 divided by 2 is 4. Good one, Miss Humbert. So then I notice here that my leftovers are matching, so I can write those out. And then I'm going to write what's left after that. So this right here is your final factored form. But now we have to use the zero product property, because if you recall, that was initially set equal to 0. So x plus 4 is equal to 0. X plus 2 is equal to 0. So now we need to solve each of those for x. So for the first one, I'm going to subtract 4 from both sides, and I get that x is equal to a negative 4. Then I'm going to subtract 2 from both sides, and I get that x is equal to a negative 2. So you have x is equal to a negative 4 and x is equal to a negative 2. So that concludes your note video today. Go ahead and show me your completed note sheet when you're done, and I will give you the homework. Thanks for listening.